Hi everybody, today I'm going to try to implement bubblesort, a simple sorting algorithm in C, and because I know I will mess up this project big time, I will use this as an opportunity to practice some debugging in C. So the focus of this video is not just the bubblesort coding, but also how to debug things in C. And all of this is my first time. I'm practicing. I have done some bigger projects in C before, but I've done the debugging largely via the printf statement, and I think it's time to change that. So let's create a new directory and call it bubblesort, and let's cd into that and create a new file. Let's call it sort.c, and then let's include standard io.h, and let's include, I think that's already it for now. And then as a first entry point, we need the main method. And in the main method, we can just printf bubblesort starting, just to confirm that we are compiling this properly. And then over here in the smaller pane on the right-hand side below my webcam, you can see me compiling this and executing this software. So let's just go ahead and cd into that directory. As you can see, we have this sort file now, and we can just do gcc and then sort, which will compile the file. As you can see, I have this file called aout now as well. Or we can do it even shorter than that, just cc and then sort. And I think cc is an alias to gcc. I'm not sure. cc version? What if I check that version? No, it seems to be a self-standing thing. All right, no idea. They are, from my beginner's perspective, they are too similar to distinguish. All right, but we're going to use gcc because that's the standard compiler for C. At least for most people starting. Of course, there's also Clang. This one, Clang. But it doesn't matter. So let's gcc sort.c and then start the compiled binary a.out, and it prints out bubblesort starting. So that is fine. I just forgot the new line at the end, which I'm adding now. And then I can recompile this, and immediately I can execute this by concatenating with a double ampersand, like this. And then we get the compilation and the command in one run. So bubblesort, what do we even do? We declare an array. Let's call it unordered, or let's call it just array. And the array is an integer array. Is it done like this, or is it done like this? Let's just try. And it gets some numbers as inputs. Oh, another 5 would be interesting. So what happens with duplicate entries? And maybe some list like this. So this is the array. And then what we want to do is we want to get a return value, a sorted array from a method maybe, which we invoke and we pass in the array. And of course we have to somehow implement that method first. So let's create a method. I don't know honestly if it is even a good idea to have a method return an array, because the array, if I create an array within a method, then the array will exist inside the stack frame of the method. And as soon as the method quits, the memory location of that array is not valid anymore and shouldn't be used anymore. So maybe we have to use a pointer here. Sorted int. Maybe let's make this a pointer. I don't know. And then we can we print the array? We can print it by going over the... How do we even do that? No, let's just print an end message. That's it. And then we can see how we print out the sorted array in the end. Oh god, I already note that this is going to be a longer episode. Let's see. So, but I really want to do this properly, so I'm not acting stupid. I am. So what is the proper return type? It's an int pointer. That is a sorted array. So we sort a given unordered array, just like this. And then what could be the next thing to do? The next thing to do could be, well, one issue is that we don't know how many elements this array has. So we can't just do int for int I equals 0 and then we loop over all the over all the elements of this array because we don't know how long it is. So maybe we also have to pass in a size of the array, length, and a common convention is to use size t for array lengths. So I hope I do something clever now. All right, and then we pass as an input to the sort method down here, not just the array, but also the size of int multiplied by the length of the array. I mean, we can count the entries here, but that is cheating. So let's look up C array length. To get the size of an array, you can use the size of operator. Oh. Okay, that means we can do size of array. That should be a size t. Let's call that array size, and that's size of array. And then we can return that. If I'm doing something wrong here, that's not too bad because that gives us a good opportunity to debug things, which is what I want to practice in this episode. So here we can now loop over all the elements of the array. So while I is smaller than length, I plus plus. And then we do, how about we do nothing for a start, and then we just return the array, the input array. This way we can already check what our application does right now. So let's see what happens. I will just call the compilation command and invoke the software. Let's go. Bubblesort starting, that's it. So we have no problems here. No problem so far, so which is quite good. I'm actually surprised by that. But okay, we're not doing much. What could we do as a next step? As a next step, we want to return a new array, which is a result array. So let's create a new integer pointer results, or let's call it sorted. Let's just call it sorted, and we have to allocate new memory for it, or we input allocated memory from the main method. Probably we should allocate the memory outside. Or what we could also do is we could overwrite the memory here on the input array. Maybe we can copy the input array here, sort it, and then once it's sorted, we can copy it back over to the original array. There's probably a good standard library method to copy memory. C copy memory. Memcopy. There's a memcopy function, and I have learned this in the last episode, which I did, and yeah. Wait. Let's first enable line numbers. No, not set list. Set no list. Set number. This is a bit nicer to look at. So now we have line numbers, but we can go to user lib, which contains all the C standard libraries. And here we can vim grab, and we can vim grab for the method that we want, memcopy. And then we can search through all .h files, all header files. And there's no match. Damn it. Memcopy. Okay, why is it not found? Memcopy. Maybe I'm in the wrong directory. Which directory am I in? Yeah, in the wrong one. I have to cd into user lib, and then I have to vim grab here. And now it's searching all the library files I have on my computer for the memcopy function. And then we should see some documentation about it. I don't know why it's so slow. Maybe there are quite a lot of header files, or files in general. What if I cd into user lib here? Yeah, there are probably a lot of files. Okay. While it's loading in the background, let's look up some online documentation. So, the syntax for the memcopy function in the C language is a void pointer to the first memory location, which is the target, then the string to be copied, and then the number of characters to copy. Okay. Should be quite simple, no? Let me just interrupt this search operation here. I don't get why it's so slow. What if I try to find all header files? Yeah, and then I pipe that into grep -rli, and then I do memcopy. There are a lot of files, so there are a lot of results, and that is the issue. Probably Vim is trying to load all the results into the buffer. And I have probably crashed my Vim because of that. What I should have done is I should have searched for standard IO.h Then I get a couple of results here. All those are for Windows. Or I should have probably just done man memcopy. Yeah, of course. That's the documentation. But as in every episode, we learned quite a bit here. So let's PS, and can I just terminate my Vim instance? Kill-9, and it's running at 148. It's killed, and let's open the sort program again, and now we're fine. We're back. All right, so that is some practical engineering here. Let's open the documentation again. So memcopy copies n bytes from the memory area source to memory area destination. The memory areas must not overlap. Yeah, otherwise the application would break. That is, or we would run into undefined territory. So what we do is we create a copy of the array, input copy, and we allocate some memory for it using malloc. We say that we want the length times. We want a memory area of length multiplied with size of int, because it's an integer memory area. And then we cast the return value to int pointer. And I'm probably messing up something here already. And then I would like to free that memory in the end. So what we do is we do free input copy. I think that's it. There are just a couple of warnings which I'm not happy about right now. So let me go back to the projects directory, bubblesort. There we are. And let's try to compile the software and execute it. And we get a couple of warnings. And there are problems with that code. First of all, malloc is implicitly declared, which means we haven't included the required library. And we even get a suggestion here. Note, include standardlib.h or provide a declaration of malloc. So that's nice. The warnings even tell us what to do this time. Oops. Include standardlib.h. Okay, and now malloc and free are imported and the compilation should work. Yeah, it works. And now, because we want to write good code, what we can also do is, let me switch the compilation window over here and the other one there. Because we want to write good code, what we can also do is we can append the following flag to the compiler, w_all, which gives us all the warnings about the code. And here we get a warning. If we compile with this compiler command, with this flag, there's an unused variable. Okay, and that is expected because it's the sorted array, the p sorted array at the bottom of the main method. All right. So we have copied the input array and we can probably printf the input array to the console. And let's see if it, oh wait, I didn't want to work with printf statements. I didn't want to work with printf statements this time. So maybe let's not print stuff. let's try to do something directly. So what we want to do is we want to loop over each entry in the input copy. We want to loop over each entry in the input copy. And then, what do we then do? We check if an entry is bigger or smaller than the next entry. And if it's bigger or smaller than the next, then we flip them, then we switch them. So what we do is we get our first element, input copy at index I. This is valid because input copy is a pointer. We just have to be careful not to access the pointer's contents beyond the length. And then we say this is the int bubble. This is the current bubble. And now the question is, does this bubble up through the other entries of the array? Then the next thing would be to get the next bubble. No, not the next bubble, but the next number. Oh, let's not call it bubble. Maybe it's a bit confusing for some. So we have a current number and a next number, a next number in the array. And that would be input copy at I plus 1. Of course, we can only access this entry if I is smaller than the length. No, not even that. If it must be smaller than the length minus 1, I think. So only if that is the case can we access this number. And actually we can also code this here directly in the head of the for loop. Yeah. So we access the current one, the current value, the next value, and then we check if current is bigger than next, then we should flip the numbers. And now what does this result in? So we get the biggest number at the end of the array. So we get an increasing order, which is, I think, good. Yeah, that's the order I want. So we get an ascending order. Yeah. So if the current value is bigger than the next value, then we flip the numbers. And how do we do that? We flip them in the array, in the input copy. I think we have to create a switch method that takes the input copy array and then the index I and the next index. So it takes as input the indexes to be switched. Oh, and switch is not a good method name because it's a reserved keyword. So let's call it flip. And then we create a new method, flip, which flips the entries of an array, int array. And then it takes, well, a size t index I and another size t index j. And then we we also, of course, have to adapt the data type of the for loop index. Yeah. Alrighty. And if we flip, then let's print flip. And now it's getting a bit boring, I would say. So let's jump into the debugger and see if this application even works so far. So what we do is, or what I do is, to get this working in a debugger, we have to compile it. Or no, let's just open the thing in a debugger and see what happens. So we have this out file, and let's call GDB with out. Out. Come on. Yeah, and that's the that's the textual interface of the debugger. It's quite bare bones. And as you can see in the bottom here, it's trying to read symbols from out, and then it says no debugging symbols found in out. So there's still a help, and we can do things if we know how, but it's not really what we need for debugging. For debugging, we need to compile the file. I'll use the WAll for enabling all warnings. So it still gives me that unused variable warning. And what we really need is the -g flag. And -g is enabling the compiler to add so-called compiler symbols. Good. And now we have compiled the application. As you can see, it has now grown in size. So here it has a size of 20 kilobytes, but up here it was just 17 kilobytes. So it added 3 kilobytes of symbols. And those symbols include the source code, I think, and well, any logic, any metadata that is required for debugging. So let's GDB and then out. And as you can see, we are reading symbols from out and succeeding. And now this interface here is not helpful at all, but it is the default interface. So to fix it up, or to get to the useful interface, you type layout next and then press enter, and there you are. And it says no source available. Why is that? If we hit enter again, we even see the compiled assembly code. Oh, and there is some source code up there. Okay, I've hit enter a couple of times. I don't know why it finds the source code now. Let me just quit that all of that. How do I quit? By the way, I've written a small notebook of commands here. Don't know if you can see that, but those are some GDB commands that we will check out in this episode. So the first, I want to know how to quit. Quit. Undefined command. Maybe Control D. Yeah, Control D seems to work. So let's again GDB out, then layout next. No source available. Layout next. You can either type layout next, or you can just hit enter and it will jump to the next layout. Well, and there seems to be one layout where the source code is found, and using the up key and the down key, you can skim through the source code just like so. And you can either now call the run command, which will run the entire application. Let's do just that. And as you can see, it started the program and the application exited already. Now the layout is a bit messed up because it printed bubblesort starting, which is coming from the print out statement up here. it printed that to the console into the GDB, and we don't really want that all the time. Sometimes this textual interface is then messed up because of those printout statements. So what we can do is we can type refresh, and that fixes up this view. So as you can see now, we don't see the printout statement here anymore. Then, so this was run. This just runs the application normally, but we can also we can set a breakpoint on the main method. As you can see, there's now this breakpoint here. And if we do run, then we stop at this breakpoint, and it's now highlighted. Now the downside of that is you have to type break main and run. Obviously, that's not always what you want. So let me just, oh no. Wait, how do I continue? Continue, yeah. Okay, and let's refresh. The downside of this is you could do all of that in one command. You can just type start, which is the same as break main and run, but it's just in one command. And to navigate through the code, you can type next, and you are brought to the next line of code. And if you type N and enter, then next line of code again. And as you can see now, because of that printout, the TUI, the textual interface, is now messed up. So let's type refresh, and that fixes up everything. So let's go next and next. And I would like to know the value of the array size. And to do that, we can do print array size. And the array size is 40. And that's all. I think that's already a bug. Or is it? I mean, what I actually wanted the array size to store is the number of array entries. But this is the total size of the entry, apparently. Wait, how many entries do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because we have 10 entries, each is 4 bytes, the array size is 40. So that's already quite useful. And that's the entire point of debugging. If we, for example, want to print out the array, we can't just do print array because, oh, we can. Good God. Okay, if we used a pointer, I think this wouldn't just work, but we will see that later. There's a special syntax for those. There's something like print array at 10. So you specify the array you want to print and then the 10 elements, and that will print what's that? This printed out the elements of the array. Then I think, well, that looks like memory locations. I don't know. But this is this is an array. This is the complete array. This is another thing associated with that array. I don't know. I think it was just a wrong use of this at 10 function here. And what happens if we dereference the array? Array at 10? Yeah, that gives us the plain array. Interesting. I'm just wrong. My use of that method is just wrong. All right. Then let's move through the code again. And that's it. That's it. Refresh. Run. No. Continue. That's it. Refresh. So what do I want to do? I want to see if the input copy is properly copying the int array. But of course it's not, because we haven't even used the memcopy function. We have just allocated the memory here, and then we are already doing the logic, which of course doesn't work. But we can set a breakpoint and see what happens, and I'm wondering a lot about this because we don't even get any errors. So let's put a breakpoint in line 11, and let's run the software. And now we are at the first breakpoint, continue. We can also clear the breakpoint at main. And let's continue. And here we are now at breakpoint 11. And then let's go next. And now we can print the input copy. And I think this won't work because this is a pointer. Yeah, so we get, well, it works in the sense that it prints out the content of the input copy. But if we want to see the contents, then we have to do print input copy at 10, because we expect it to have 10 entries, and go. And as you can see, we have a couple of memory addresses here. They may be valid, maybe they are not, I have no idea. And if we do print dereferenced input copy at 10, then we see that we do have a lot of entries here that dereference to 0. So the array is currently empty. So this is a bug that we have to fix. Let me just create a new view here so we can continue our development here independent of the debugger. Just like this. And let's go back to bubblesort and then vim sort C. So there we are, set number to enable the line numbers, and we were at line 11, input copy. What we want to do is we want to mem copy into the destination pointer input copy from the source pointer the length. And the length is in our case now the number of bytes, which is completely wrong. So we have to fix up this array size. As we saw in the debugger, it's currently the number of bytes, but we don't want the number of bytes. We want the size. We want the number of array entries. So we have to divide the size of the array by the size of the data type of the array, which is an integer. Well, it's the data type of an array entry. Okay. Size of. Okay. And this should give us an array, maybe number of array entries. Oh no, array size is actually fine. In most programming languages, you call the size method on an array, so this should be fine. But in C, you have to be very careful about sizes because you can refer to an absolute byte size, or you can refer to the number of entries of something. All right, then let's annotate the sort method with some documentation. Sorts the entries in the array. Length is the number of entries. All right, so we allocate length multiplied by size of int, which is fine, I hope. And yeah, here it makes sense because we have x entries, length entries, and then we multiply them by size of int. Size of int is 4 on most systems nowadays. And then this results in our input copy memory space. And then using memcopy, we copy into input copy the contents of the array Okay, let's see if that even compiles. So let's do gcc sort.c w_all and enable the debug flags, and let's see if we get any warnings. And we do get some warnings about memcopy, and we get a very helpful warning. Let's see if we also would get it without the w_all. Yes, we also get it without the w_all. We have to include string.h, which is hosting this memcopy function apparently. So let's import string.h. And this worked. This works as well. Can we execute? Yes, we flipped twice. That's funny to see. Does that even make sense? So we start with 5 and 1 should be flipped, and 6, 5, 3, and 9 should be flipped, 14. I don't know. But we're not at the stage yet where this code is complete. So we have copied stuff into the input copy. And I would be wondering if this now works, and we have to check this in the compiler. So let's quit the process, restart the software, and let's go to the next layout. Layout next. Let's hit enter a couple of times, and there's our source code now. And let's create a breakpoint after the memcopy function, or maybe at the memcopy function. So let's do break 14. So we have a breakpoint at line 14, and let's run. And now here we are. Then the next thing to do would be refresh. And what I would like to do is I would like to put a watch on the input copy, and this will print out whenever the value of input copy changes. So right now, input copy has that value, and that shouldn't change. That's just the address. So can we dereference right here? Yes, we can. The first entry is 0. Oh no, don't quit. Input copy at 10. So this is now our empty array. We can also print the length. It's 10, so that is fine. And we can print the dereferenced array at 10. And here we get those entries. Those are the entries that we defined at the beginning of the main method here. So they are matching. This is very good. Let's go up again. Then let's see if we hit next, if the watch is activated. No. And maybe that is because the value of input copy didn't really change. It's still the same memory address, but the content of the memory location at that address has changed. And that is of course hard. I don't know if that's even possible for a debugger to catch. So let's just try and see what the content of input copy at 10 is now. And as you can see, we have copied a couple of the entries, but not all of them. And that's what you need a debugger for. You wouldn't figure that out so easily without a debugger. And here it's now easy to tell, because why did we copy just the first 3 numbers but left out all the rest? I give you 10 seconds to think. That is because, where did we come from? Here, memcopy on the array length. And of course we have to do length multiplied by size of int, because the length here is just the number of entries. If we enter the number of entries in the memcopy function, which is 10, the number of entries is 10, then memcopy will interpret that as the number of bytes to be copied, which is not the same as the number of entries, because each entry is a single int, and an int is 4 bytes. All right, that means let's quit the application, let's quit the debugger and compile this again, and then enter the debugger again, layout next. Here we go. And let's just set the breakpoint at line 15 and see if the input copy was properly copied from the input array. Print input copy. This is awesome. I love debugging, by the way. It's one of the biggest bottlenecks for most software engineers. So if you can improve one skill as a software engineer, usually if you become better at debugging, it pays off a lot. So yeah, if you don't know what to learn, learning about debuggers is never a bad idea. It's usually quite simple and it's very powerful. So let's print out the input copy at 10. And it doesn't work. No symbol. Okay, that's because it says no symbol input copy in current context. That is because the current context is nothing. We don't even run the application. So now the application is running. Let's refresh the screen. And now the context is the context at breakpoint 15. So let's print the input copy. And here we go. The array has been properly copied. Wow, I feel like a magician, honestly, with the debugger. I've been doing that. I've been doing all of that using printf statements. So, and using printf statements to print out the input copy's contents, you would have to create a small loop where you just loop over all the entries manually and then print out the values. Horrible. I don't know why. I didn't even think of learning about the debugger. No idea. So much wasted potential here. But now I'm doing it. Finally. And maybe you're also taking away a couple of nuggets here. Okay. If the current value, so we can now continue developing our stuff. If the current value is bigger than the next, then we can flip the values in the input copy here, up here, flip. And by the way, before I continue, that's probably the reason, the previous bug that we encountered where the input array was improperly copied, that was probably the reason why just 2 flips occurred, because after that the input array was zeroed out. So maybe if we execute the application now, it will, it flipped a couple more times. So maybe it's now it's now working better. So how do we flip arrays in an entry? First of all, we have to get the array entry. So let's get the ith entry, and the ith entry is array at accessed at I. Then the array accessed at j. Wait, the jth entry is the array accessed at j. And then we can say array at I is the jth entry, and the array at j is the ith entry. I think that should do it. I know it's possible in 3 lines, but I think this is a bit clearer in most cases. So what is the next thing to do? The next thing to do is I want to check in the debugger if the flipping works. So let's quit. Or maybe we don't even have to check if the flipping works. We can check if the entire thing already works. Maybe it's already working. So let's compile and then GDB a.out. And here we are, layout next. Let's jump through the layouts and then let's set a breakpoint at line 40, which is the last line of the entire application. So break 40, then run. And here we are. And now we can already check the sorted array and see its contents. So let's do that. Print dereferenced p sorted array with 10 entries. And this doesn't seem to have sorted anything. So what is the reason? Why didn't we sort anything? That's quite discouraging. No, just joking. This is the entire fun of all of that. So let's refresh the screen to fix up the terminal user interface. So here we are flipping the entries. It seems as if the flips don't change anything in the actual array. And that is probably because here in the flip, we are inputting the input copy, but we are returning the final array. We are returning the original array, and the input copy is just, which should be sorted, is just freed and never used again. So let's go over into the source code and let's do copy the sorted array into the original array. To do that, we can probably use memcopy again, memcopy. And we can say the target address is now the array. The source address is the input array, and we copy length multiplied by size of int. Oops. Use of undeclared identifier, input array. That's wrong. Input copy. Okay. Now going back to our compiler, let's exit this. Yes. Let's compile with all the warnings and see if there are any warnings. No warnings again. At least no meaningful warnings. And execute GDB a.out. I really love programming, guys. This is my what is it called in Japanese? There's this one concept of the thing that makes you happy, and this is somehow frustrating, but it makes me happy at the same time. I forgot the name. Yeah, programming makes me happy and frustrated at the same time. But after that programming session, I'll have a nice cold shower, and then this feels like something. This feels like I've learned something. Okay, so layout next. Layout next. Enter. Then set. No, not set. Just break at line 42 and run. Refresh. And let's print the sorted array. Let's print the dereferenced p sorted array with a size of 10. And this is not sorted. It looks sorted at the start, but then it's not. why is it not sorted? I think I'm just bubbling up. I think I need more bubbles, more of that up bubbling stuff. So here I am switching up the current and the next entries of the array, but once I have passed over the entire array once and one bubble has risen to its designated place, then it doesn't do anything anymore. Wait, what also bugs me is this 2 at the end. How am I supposed to sort that down? Okay, what I want to do is I want to go over each entry in the array, so 1, and then compare it with the next one. 1 is smaller than 5, so it can stay there. Then 5 is equal to 5, so it can stay there. 5 is bigger than 3, so we must flip them. Why were they not flipped? Or maybe they were flipped, but we haven't passed over the array enough times. Yeah, I think they were flipped before. In the original array, the 10 is also the last entry, as you can see here. Yeah, so we have done a couple of flips, just not enough. But how do we do it then? I mean, how often am I supposed to pass over this input array? So here I flipped the 5 and the 1. Then I flip the 5 and... No, I don't flip the 5 and the 6, so they stay there. Then I pick the 6 and flip it with the 5. Then I flip the 6. Yeah, that makes sense. And as soon as a big number is encountered, for example, there's 14, it acts as a wall and nothing can flip beyond that. But the 14 should flip with the 2. Why didn't the 14 flip with the 2? It didn't flip with the 31, but 31 flipped with the 2. That's why. So if I is smaller than length minus 1 and the input copy is not sorted, we have to check that whether the input copy is sorted. And only if the input copy is sorted, then we then we terminate the loop. And for that we have to create a new method that returns an int sorted. It acts based on an integer pointer array of a length, I would say size t length. So sorted input copy length. And then we return, then we go over the entire array for int. I don't know if this is the most efficient implementation of bubblesort, so please bear with me. I smaller than length, I plus plus. Maybe this is not even bubblesort. Maybe this is some freestyle sort. Please put it in the comments below. Am I even implementing the algorithm correctly? So for int I equals 0, how do we check whether the array is sorted? We have to check we have to store a biggest entry so far, and it starts with, what does it start with? Probably with the smallest possible integer. C smallest int. Use int min to get the smallest signed integer in C. Do not hardcode the value. Yeah, so I'm going to use that. Include limits.h, and then the biggest so far is the int min. Yeah, seems to be working. This returns the smallest possible integer, and if array at index I is bigger than biggest so far, then we say biggest so far is I. Bigger than biggest so far. Wait. So we have an array with a couple of entries, 1, 2, 3, 4, 5. Wait, how do I programmatically check if an array is sorted? This is just breaking my brain. Oh, maybe we can do it way simpler. No, we can do it way simpler. For int I equals 0, and int goes up to length minus 1. And we check for every entry if array at I is bigger than is smaller than, if array at I plus 1 is bigger than array at I, then return 0, it's not sorted. So if it's smaller. So if a next value is smaller than the current value, we return 0. If a next value is smaller than the current value, that means the sorting hasn't been applied properly. Okay, and else we return 1, which is true. And aside from that, I think we are good to go here. I get this warning down here, expression result unused. Let me just open the compiler here, and let's call GCC with the warning flags just to see if we can get some more info about that. There it is. Basically I missed a semicolon. Oh, and a value computed is not used, but this is not the case. Probably everything comes from the missing semicolon. But where's the semicolon missing? Where's the semicolon missing? It's missing in here? No, this is just the closing parenthesis of the for loop. So maybe I messed up the parentheses somehow. So I is smaller than length minus 1 and sorted, and the input array is not sorted. What the hell am I doing even? I mean, if it's not sorted, then we even have to reset the counter somehow. Wait. What is... and there's a semicolon required here. Okay, that's the issue. Okay. So maybe this needs to be a while loop. While not sorted array, and then or maybe input copy and length. While it's not sorted, we use this integer I as a counter. Then the int I is incremented here. And if I is bigger than or equal to length minus 1 maybe, then we reset it to 0. No. Maybe we should do that at the start of the while loop. So I is reset to 0 if I is equal to or bigger, which shouldn't be possible, but actually equal to length minus 1. Then I equals 0. That compiles and we just get a simple warning. So maybe this is working now. So now it's at least looping over the array and bubbling things up until the entire array is sorted. I don't know. Did I just undo something? Yeah. Let's not undo things. Let's compile again and oops. It flipped quite a lot of time now. So this is a regular execution now. Wait. Messed up the layout. Okay, and here we do gcc out, and we go into the debugger right away, layout. Oh, it says no debugging symbols found in out, so let's quit that and attach the -g flag. Layout next. Now we are already proficient at it. And then let's go into, well, I would say at the end of the method, line 56, let's create a breakpoint there, break 56, and let's run the software and refresh, and let's print the p sorted array and see if it's sorted. P sorted array, and we print the 10 elements of it. And there we go. The array is sorted. I think that's it, guys. I think that's it. We can now also, just for fun, let's increase this input array by many numbers here. And see if it can handle that. But we shouldn't be limited now. Okay, just the last test. Quit, compile, layout, next. Then layout next, next. Break at line 56. Let's go up a bit, run the application, refresh the screen, and then let's print the destructured p sorted array at, oh, I don't know how many entries it has. So maybe we should print the array size first. Luckily we have a variable for it, 27. Okay, then let's print the dereferenced p sorted array at 27. Let's go. And this is a fully sorted array. And that, my friends, is debugging in C with the example of bubblesort. I hope I didn't mess up and change up this algorithm completely. I just implemented some sorting algorithm. I think it's called, it's the bubblesort. If I did it wrong, then please let me know in the comments. But the main point of this video was to practice debugging and share some debugging tips here and just have some fun coding. If you enjoyed this video, please come back to this channel and see you next time. Bye.